So, hello everybody. This is the microservice lecture at Join Douala and Kassel, and it's winter term 2021, and it's the 10th or 11th lecture, and we will have this lecture and two more. So this course is going on for this week and 2 more weeks, if I'm right. So we need to go forward fast. So and we are currently connecting our shop to our warehouse. And so actually the idea is that finally we will have a lot of people using a React app on their computers or browsers to connect to one warehouse service. I should show you that. There will be multiple clients that connect to one warehouse service, only one, which has one event store on its own, and only this warehouse service is accessing this database here. And there is, in addition, a shop service. And there are a lot of clients that are working on the shop service or connected to the shop service. And the shop service has its own event stores. And the warehouse service and the shop service, those two are going to collaborate. So whenever anybody, Bob or Alice, enters a new product to the warehouse service, we want this product to be forwarded to the shop so that somebody at the shop site can put it online and some customers can buy it. Actually, the full idea was that you have a more complicated process where you first order something, shoes from Italy, then those shoes are going to be delivered and then they are stored at a certain shelf within your place or position in your warehouse. And only then you are going to send it forward to the shop, and the shop is going to sell it, and then you can buy it. And then if you buy it, there will be going picking requests for please collect it from the warehouse and then send it to Alice or to somebody from the shop to the warehouse service. And as soon as this is done, so the goods are sent out to the customer, this would ping back to the shop service, and the shop service would send the invoice or something like that. So there is a lot of communication between those two, and we would like to have this. The idea is that all the communication is happening on the service level. So the shop service will never look into the event store or database of the warehouse. The warehouse will never look into the shop event store directly, but it will ask the shop service for certain information. And for the shop service, there's little difference whether a request for what products do we have currently comes from a web client or from a partner service. That's basically the same thing. The big point here is that the clients on the top level, you start them and they connect to the warehouse service and they do requests, queries and submit events to the warehouse service. However, the warehouse service never pushes events towards the clients. This is a restriction that comes basically with the web. Actually, there are tons of clients, hundreds of thousands or millions of users for a single service, and it would just be very hard for the service to keep up connections or aware of which of my clients are currently online. And therefore, you usually do this that you say, okay, the clients need to pull information, and then I tell them, and then I forget about them. So the service does usually not do push notifications to the clients. So there's some new product, and then I would send a customer who is currently shopping at my shop site a notification. Oh, here are these very cool shoes, and that's never happening because there are technical restrictions. Come on. However, the two services, they would like to inform each other directly. You do it with push notification. If you do not have push notification from the service, you need to do pulls. You usually do this with a timer. So once a second, the client asks the warehouse or the shop client asks the shop service, is there something new that I should show on this page here? And you can actually do that in your browser, put something in there, some code in there that does this requests all the time. However, doing pull requests with a timer or loop is always a bad thing because, well, actually it creates a lot of traffic. So the user has this website open for half an hour, and every some second you do a request here to the shop service with getting all the same information. Nothing has happened in between, and that's a bad thing. And the other bad thing about these timing things is it's really hard to test. Writing a JUnit test or a Cypress test or whatever test that needs to wait for a timer happening is not that easy. And as soon as you are going to debug one of those processes, all the timing behavior is going to be, well, corrupted. So there is the test says, oh, it should respond within 4 seconds. And then you stop it in the debugger and you look for it some minutes. And so the timer is already outdated and yeah, your test fails because you are debugging it. That's not a good thing. So we try to avoid this, and therefore we say, okay, those services, they shall push each other. And well, therefore, the warehouse service will go to send submit requests and query requests to the shop service, and the shop service will send similar requests to the warehouse service as soon as it is possible or reasonable. And the point is, if you fail, if you start the shop service and the warehouse service is offline currently, then the shop service tries to send some information to the warehouse or the other way around, and well, it doesn't work. The next point is services may actually move from one computer to another. So my hardware crashes and I move my service to some other computer. And the warehouse service still tries to reach the old computer. And in order to well, let the warehouse know that the shop is running or has started, the shop at the very first at startup, well, connects to the warehouse and tells the warehouse, I'm here. And similarly, and that was pretty much the thing that we have implemented last week. So if I go back to this one here, I had this shop subscribe test. Let me check what it all does. Testing product exchange. It on 34,560 there were the warehouse running, and 570 there was the shop running. I have put this into constants. Did I do that last week? I'm not sure about it. And so we create some very interesting new product. It's did I show you the shop subscribe test last week? Is this a new one? Okay, so let's go for it. The idea is actually to, well, have a test. That's a good idea. And so what we do is we assume. Yeah. Now I know why. Yeah, we assume that. Let me see. products test. We were running the products test. Yeah, we were running that one all the time and used that one for doing the stuff. Let's start some of the things. And actually, I have changed the way I'm starting things since last week because it was becoming really messy. And therefore, I go for this thing here and say I would like to add some config to the server warehouse. So this is the debug view, and I actually have changed a lot on the launch thing here. And now it says I start the warehouse server with yarn run start, or I test the, I should say, warehouse server. Come on. With yarn run test, and these are the two things that I can do with the warehouse and the shop. I have test the shop, gets product updates, and start the shop server. These are the two things that I do. And I will now first run the start the warehouse server thing and do it. So it's just a little bit more convenient. I have had a whole history of different other launchers that I was using, and I'm now using these ones because that's an easy one. And then I'm no longer getting confused. So one thing about this thing, testing this, distributed setting. So I have the server for the warehouse, the server for the shop, and the test running some scenario. And that's a hard thing to achieve and to get right. So I would love to have a test that is starting the warehouse server, starting the shop server, and then starting some usage of those two, and issuing new products or something like that. And actually, that's hard to be done in a jest test, because we have split these different servers into different projects in our workspace, and I would have to reorganize a lot of things, and it's pretty hard because actually all of these servers shall run in their own express service, and they should run on their own Node.js virtual machine. And to have one test that starts multiple virtual machines is a hard thing. And therefore, for now, we are going to start the servers manually and then have only a test that tests their collaboration. Okay? And that's not the best thing to do. Finally, we would like to have Docker tests. So we would like to and do it with, we could have a script that actually does this on the command line, call the different yarn statements one after the other to start the different services and to start the tests. However, that's again hard to debug. And the other thing is those command line things are different on different kinds of machines. So if you have a Windows machine, you need a different command line with backslashes in your file names and all kinds of stuff. Then you would use on a Linux machine, which is usually the kind of machine where that Heroku runs, where we firmly are going to deploy these things. Or if you use a continuous integration testing environment, then you again need some other scripting things which are usually Unix based, and so it's hard to have something on a command line, a batch script or something like that does this thing. So after all, it's not ideal, but we will help ourselves with these things here. So I have started the warehouse. I start a shop server. and just start two debuggers. That's possible in Visual Studio Code. I have now two of those, and I can actually switch between those two. And each of them gets its own, terminal so that I can actually see what's going on. So I can switch back to the warehouse server and look for any debug output that we did there. And I could switch forward to the shop server and look at the things that are going to come out here. So it says the database exists, and it says I've got a lot of products. That's fine, great, good stuff. We are happy with this. If I kill those two and I start them in the reverse order, so that was actually the thing that we have achieved last week. If I kill those two and start them in the other order, so I start the shop server first. Can see that? Yeah, cool. Then, well, it sends a very lengthy thing saying it didn't work. And it actually says error connection refused. That's a bad thing. And that one message comes from, I have no idea. Well, actually, it comes from close the launchers, go for the code, go for the shop, go for the business model, go for the command, for the submit handler, and there we have a starting method, and there we try to do this access request to subscribe at the warehouse, and the warehouse is not up, so this is going to fail. And it's somehow unexpected behavior. And so let's change this error message a little bit. And let's say, oh yes, warehouse is not running. Warehouse is offline. And okay, let's rerun this. This means it needs a second. Yeah. No, it's done. Yeah, here it says warehouse is offline. So he thinks it's fine. I cannot reach it, of course. And so I'm now going to the debugger and then here select the start warehouse. Let's run it. It's hard to always get the right thing. So now the warehouse comes up. Cool. However, the shop checks whether the warehouse is living only when it starts. And then if that fails, it never tries again. So now the warehouse is up, but and the warehouse has a lot of products in it. However, the shop never knows. He doesn't get the idea that there is that the warehouse might have come up meanwhile that it should subscribe itself there. So that is the thing that we need to do now. And perhaps explain it here. If the warehouse service starts first, then the shop service starts. The shop service sends a subscribe here, and the warehouse then pushes all the product information to the shop. However, if we start with the shop and the warehouse is not yet there, this subscribe request fails, and the shop says, oh, I'm sorry, kind of connected, yeah, it might be okay. And then the warehouse comes up later and would be ready to tell something, But because nobody has subscribed, it never tells something to the shop, and those two are not yet really connected. So this happens if you start them in the wrong order. That's not a big problem. You could always say, okay, yeah, you need to start them in the right order. However, we are going to, well, extend the warehouse service. So if we start first the warehouse service, then the shop service. And then the warehouse service needs a restart because we have changed something to the code. So we kill the warehouse service and restart it. Then we have a new instance of the warehouse service, but the shop is no longer subscribed to that instance. Well, the warehouse service could write this thing down to its event store and load it on startup. However, if meanwhile the shop is down, then this information, once upon a time I was connected to this shop, I could probably send information to that thing, is no longer valid. And well, yeah, we could actually do it if I think about it, that the warehouse always tries to send the shop information, but does not wait for a subscription. That would be another good idea and would be easier. However, if you actually subscribe to the warehouse can deal with the information that you have moved to another IP, that your URL has changed. And again, these information to store it into the event store, the status of another service, the other service is online, is information that is outdating all the time, and therefore this doesn't make sense to me. Actually, we will later on have multiple shop services connected to our warehouse. So we will have multiple instances of the shop service connected to the same warehouse, and therefore the warehouse has no idea how many of those are there. Still, we need to establish the connection. And the idea is, the shop, when it starts, connects or announces itself to the warehouse. And similarly, we want the warehouse now to announce itself to the shop. And that's what we're going to do. I need to think about this concept a little bit more. Okay, so we go for the server warehouse for the source, for the business model. And the usual place where I would do that is the submit handler, because there everything starts. And there the start method, where is it? Is this the start method? Yeah, that's the place to be. I can actually see that if I go down here, here, and go for start. I find that there. Okay, currently, this one does a start database and a create table and nothing else. And what you would like to have now in addition is connect or tell shop that warehouse is online. Yeehaw. And I have prepared that hopefully. And that is the server of the warehouse, the submit handler, yeah. And there it is, the start method. Yeah, cool, I have it. And it should be like this. So this is a lot of code that I'm copying, And now it's unhappy with the create database because something bad is happening. And perhaps there's something wrong with the number of braces. No, it looks great. Does it? No, there's a brace too much. Okay, it says I do not have a publisher. Add all missing imports. Cool. Then it says you would like to have a constant here, and I actually have prepared that one too. Just to have it a little bit more orderly, I have done attributes, and actually, can I say they are final or something like that? Sebastian, do you know? Okay. Yeah, that's what I want. Cool. So we have read only here in order to ensure that it's not written twice, and shop. There's something warehouse query. Here we are. So this is the old constant on start, and we will now tell. So this is a double comment. What we do is we create an event, a warehouse, a publisher event, publisher data transfer object, and say, oh, there is some publisher for warehouse products. This is the URL of the 560 API query. There you can actually send a query in, or subscribe yourself. The topic this publisher is going to publish about is products, and the last known is 1970. We need to work on that one, and we actually should ask our event table for the last store time, and you should do that in your exercises. I'm going to omit this tiny step. Then we wrap this into an event. For the topic publishers, the ID you see comes from above. Take the current date time, say warehouse.start, state is online, and the payload is the warehouse publisher data transfer object that we did here above here. Then we go and say, oh, let's do Axios. And unfortunately, it doesn't work. And why does it have this here? So we cannot do the import from Axios because it's not installed yet. So we need a new terminal. Current working directory will be the warehouse. And then we do this yarn at Axios and the types for, is this a slash? Yeah, Axios. And we want the safe version, and we want it for development. And we want it for deployment within our system. So if we go back to this guy, we now go for Axios. Let's save it once. It should actually say I can import that. I have no why, dear why doesn't do that. Axios from Axios. So here we are. Let's close this one. Still the start method. We created the event and we do a post to shop submit. Shop submit is 570 submit, so the usual URL that you need to go for the shop. And actually these two constants here are still an open problem. So we have now hard-coded in our source code where the warehouse believes that the shop lives and where it believes that it itself lives. While this might be true for itself, well actually no, it's not true. So localhosts, no. That's usually not, as soon as you go for Heroku, that's no longer true. And actually somebody should tell the warehouse on startup how to fill these constants. So that it knows, oh, currently my shop is living over there and I'm living here. And we will actually do that with the help of environment variables. And that is something that will come up when we deploy the whole stuff to Heroku in 2 weeks. And so we need to deal with these later on. So currently we actually do this. The idea I have is as soon as the shop receives this, oh, the warehouse is finally up, it will send a subscription to the warehouse. And then the warehouse will react to this subscription directly by telling the shop all the important stuff. The exciting products it have. And so you see, the warehouse is currently starting up. Then it tells the shop, I want you big. So the warehouse is starting up. Then the shop is already there. Then the warehouse tells the shop, hey, I'm alive. Then the shop says, oh, so cool, please send me all your, I would like to subscribe, send me all your things. But that guy here, the warehouse, is still in the startup phase. So it is not going to respond to this subscription. Subscription will fail because startup has not yet been done. And that's a tricky thing I was fighting sometime yesterday or actually on Saturday when I was preparing this here. So you need to be aware, we cannot just as usual say await. So if you put an await in front of this post, then the startup would stop it. And actually the warehouse server would never really start. And yeah, that's bad. And therefore, actually, because the actual starting of the Express service is done in this index TS, and before that is done, the submit handler is instantiated, and so we cannot yet answer to that queries. And that would be a deadlock. And therefore, we do not do an await here, because that won't work. However, but we put a then here. We still want to, know or react to, did this work or not? So, however, we cannot wait for this to happen, but we need to go on in order to start the Express service such that it can happen. So we schedule this asynchronously and go on with starting the Express service. And when finally the result comes, we provide an operation, or actually two operations, to be called on response. So when this thing responds, and this is this is the thing that the then operation does. It stores two lambda expressions at our post operation, and when it succeeds, then the first lambda expression is called with a response, and I can do a console log warehouse announce product publishing to the shop, and this is the response data that we got. It's probably the request that we have sent, and in case of an error, there is a comma here, so the then has two lambda functions as a parameter, and the first one is the operation to be called on success, and when it will be called, it will say, hey, it did work, and on error, the second function is called with an error message, and we just say, hey, warehouse could not reach the shop, because, well, if the warehouse is the first one starting, that might happen. Okay. But really, this is something you need to be aware of. When those two start, and he's in the process of starting, he cannot yet respond to, or it cannot yet respond to requests. And so you have a deadlock, and you need to, well, resolve this by using then here instead of await. Sebastian, you agree? You go with that? Sebastian is still thinking about it. Okay. I need it's necessary. I think it's necessary. I didn't try the other way around, but yeah. Okay, cool. So if we now do this, this says we go for the. So we have all these things are still running. The warehouse server is still running and the shop server are still running in the debugger. And so we now go for the debugger that is for the warehouse and say, oh, stop or just restart. So the shop is running all the time. And now we just do a restart. Trying to announce warehouse products online to shop, and then it doesn't tell anything here. Yeah, I had this yesterday, on Saturday. And if we go for the shop server, we see, oh, damn it. That one was actually, yeah, sorry. So we have had these. Okay, let's have this situation. Was talking about the code again. No. Server shop, no. The warehouse here. Yeah. Let's close this one. So I was talking about this then here. So you didn't see it. Why didn't you tell me? I was talking about this then here, and that has two parameters. In case of success, it's going to print to the console, hey, I was able to do this. In case of an error, it tells to the console, warehouse could not reach the shop. And we do this with a then here, instead of putting an await in front of this Axios post, because the await would actually, well, wait until an answer comes, and if no answer is coming, then you do have a problem. So, and then I was restarting the warehouse, and now I'm looking at, and it didn't work after all. If I go for the warehouse thing here, it says, oh yeah, the warehouse database exists, and I'm trying to announce the warehouse product online to the shop, and the server started at 4560. So yes, it was going over this thing here. It did not wait for a response, but went on starting the service. That one was coming, but none of those two messages is coming. Which actually means the post has not yet been successfully executing. If you wait for some more 4 or 5 minutes or something, it should actually finally time out. However, if we go and look at the shop server debugger, then that one says warehouse is offline. So that was once upon a time. Server has started. And then there's an unhandled promise rejection warning. Ooh, handle, blah, blah, blah. There was an exception. And it's in submit handler JavaScript. No, it's in submit handler in this one. Handler.handle, and we are in the server shop. Yeah, that's where I expected it to be. So, this is the submit handler of our shop. The submit handler just got a message, there's a new publisher. However, if you go up, the constructor says, I have a handler that is able to deal with messages, with things that are related to products. But I do not yet have a handler for publishers. So it's actually, we did not yet implement it on the shop side that there is a new publisher event coming up. So we need to do that, obviously. So we say this dot, I actually copy that, that's an easier one. The server shop submit handler. Here is the line of code. Yeah. We say, oh yes, a handler, we need someone who handles new publishers, and we will use a publisher command handler, of course. But we do not yet have a publisher command handler, so we create a publisher command handler. A new file. Yeah. Right. Publisher command handler TS. Hope that does the job. And I have prepared that one. It's not that big, but convenient to just copy it in here. And that one needs to go away a little bit. Here we are. Some of those are unnecessary. Okay. This says, oh, there is a new event coming from some publisher that is now has just become online. How cool. So what I do is I will subscribe at that warehouse. However, this subscriber warehouse is a new method that I have extracted, have created and from the old submit handler, and I just need to store that one. So we now have a publisher command handler. We import it. Great. So that one is gone. So currently at start time, we do these things here. Subscribe at publisher, do subscription, and then wait for a response and these kinds of stuff. And actually what I'm going to do is I will put this into a new method in order to be able to call it when a new publisher arrives too. So I will have to execute the same thing, but let me just double check that this is what I do. Yeah, that's exactly what I do. And that one then goes for the server warehouse submit handler. No. I'm server shop Submit handler. I'm looking where I did this. Subscribe at warehouse. Yeah, okay. So just kill that code. Come on. It's up to here. And it's up here. Is there a refactoring for that extract method? Okay, it's Control X. I think I call it subscribe at warehouse. Yeah. So why not? That one doesn't need any parameters. Is this true? Yeah. But it has a lot of code. The code that I've extracted from the thing above. And here we do an await subscribe at warehouse. And actually, we could think about doing this with a then here either. I'm not sure what the good way to do this. Do it here, but come on. So let's check it. It says it creates a publisher object. Yeah, I don't think that we need that anymore. Perhaps we do. Yeah. Yeah, no, this is the way I have it in my done on Saturday. So let's stick with it. It calls have publisher on its publisher's editor to store that one. I'm not sure whether we really need that. Then it creates a subscriber, and that's itself. And then it does a query with access to the publisher URL, the one above there, and looks fine for me. So basically, hopefully this is doing the same thing it did before. And let's stop those two and then try to put this in a different way. And this subscribe at warehouse is an operation that we are now able to call here. Subscribe at warehouse. Cool. So we have written a command handler. Now let's have a look at the overview. We were editing the shop service, and the warehouse, if the shop is already running, then the warehouse starts. It sends a hey, I'm online publisher event to the shop. The shop now has a handler for this, and that handler just says, oh great, I subscribe at your site. And as soon as the subscription comes in, this one replies to this query that we have created with all the current products, and so the shop should know. If we restart the warehouse, it will again publish I'm online. Again, it will get a subscription. Again, it will send all the information. Note that this is happening. There are always these two cases. So if the warehouse is already up, the shop is going to send this query for subscription during startup. And we did this await in there. And that's okay because, well, the shop is not yet ready to accept requests, submit or queries. However, it is ready to send out something, and on the same, message exchange, it sends this query and gets a response. This is one thing that's possible, that can be done, and I can wait for that. I do not really need for And we need to discuss this concurrency issues a lot more, but for now, let's do it this way. So now it should work in either direction. So let's go for our debugger again, and well, we start with the shop. Is this okay for you? Start shop, run it. This takes some time. So the shop says the warehouse is offline, but itself it's now running. So, but it did not yet do the subscription. So we now start the warehouse. No, not the test, but the service. Start the warehouse server. Yeehaw. So a second virtual machine is starting. And we look for what it's doing. Still compiling. Yeah, it says, okay. Warehouse announced product publishing to shop, and the shop was answering, yeah, that's okay for me. Cool. And if you go back to the shop server, then it says, oh yeah, server has started. And after it has started, it says, oh, there are products coming up. Isn't this cool? And shop did subscribe at warehouse. Yeah, it worked. Cool. And the coolest thing is if we go for the warehouse, let's start it again. And we switch to the shop. And if we are lucky, it will subscribe again. Yeah, did you see? Anybody see? It was, well, scrolling through. And we need some times added to this to see it actually. There is shop did subscribe. And after that, yet again, a shop did subscribe. It did it twice. So cool. I love it. That was working. So now we are ready to go for this subscribe test. We should test if this works when the warehouse is running and the shop starts. So let's restart the shop. Start shop server. Hey, yeah, it gets a lot of products. And it did subscribe to the server. Great, and the server is still there. And that one is happy with itself and everything is cool. Great. I love it. That's actually what I wanted to achieve. So usually during development, I have both of those things running. And from time to time, I do some changes or add new features to one of those servers. And then I just restart that server, and the new instance of that server is connecting itself to the other still running service, and they still talk to each other. That's great. That's what I wanted to achieve. It might still happen that one server goes down, so the shop server goes down, and then the warehouse says, oh, I have a new product. And then it actually says, let's go on. And tries to send in information towards the shop. Yeah, the warehouse tries to send in information to the shop, and the shop is down. And then we'll actually, remove the shop from the list of subscribers and say, oh, it's offline. I'm no longer going to send information to that guy. This is somehow a circuit breaker. Circuit breaker is a design pattern for microservices that says if there are two services that try to talk to each other, and then one cannot reach the other, the warehouse cannot reach the shop. It's a bad behavior for the warehouse to try again. Because if, well, I send a request, it doesn't answer, I send another request. So I actually spam those poor little servers who's down with a lot of messages. Some of these messages are going to be queued. They have a timeout. It might have 4 or 5 seconds or something like that. So if now the shop starts, it comes up and there is a mob of requests waiting at its doors. And so while it's still starting up and shaking itself and trying to initialize, it already is bombarded with requests and then the bad behavior. And it causes traffic. And so waiting for a timeout will delay execution of the warehouse a lot. And so it's a bad idea just to keep trying and waiting for the thing to do, because it will block yourself. And for these good reasons, when you know, oh, the other guy is down, so you say, oh, he's probably ill, I won't talk to him for a while. And when he comes back up, it will announce it's healthy again and then I'm going to talk to it again. And that's actually the thing that we have achieved with the publish subscribe pattern that we have been implementing here. And there's a lot of things that are very tricky and are about scaling. And so this is the solution I came up with. And again, we will need to discuss at the end of the lecture what did we actually achieve in doing all these things, and what are still open questions. And I need to go back to this slide here. Microservices is a lot about scaling web applications. And there are different directions in which you can actually scale if, well, the thing grows. And there is, you can go from one instance to many instances. So this is what Google does. So instead of having only a single computer answering Google requests from customers all over the world, it has hundreds, thousands, or a ton of these servers, which all do very much the same job. You send them a query, they answer it, give you links. And this is, you have many instances. What you can also do, and this is working if, well, things are easy. So if you have so many instances, writing new information, so changing something in the Google database requires actually to go for all those 1,000 servers and tell eachbody, oh, the URL for microservices at University of Kassel has moved. The content is somewhere else, or there is an update, there's new information in that page. Please add that to your database. And actually, this is what Google does. And however, if I actually change my website, I will have to wait about a day until the Google bot comes and looks at my site, then it will recognize it, and then it will again use about an hour until this information, Albert has a new link on his page, is spread through all the different servers all over the world. So it might happen that someone who's doing query for Albert's web page or for a certain keyword that is now in my web page will find it in Germany, but it's not yet in the US and it's not yet in Cameroon. And some hours later, Cameroon server know too, and then they will also deliver the new information. So if you have many instances, writing becomes slower. And then the alternative is, what you do is you do partitioning. You actually says, okay, all queries that are related to microservices are on that server. All queries that are related to cooking recipes are on that server. And so then you do, oh, what is this query about? Okay, go to that server. Oh, what is this query about? Oh, go to that service. That is hard for Google because, well, you enter some text and they do not really know about where this is. However, in our Warehouse, that's an easy one, because we can actually say, okay, we have a certain topic. We have these topics, and then we can actually split our services into multiple services and say, well, for this topic, only that guy is responsible, and for this topic, only that guy is responsible. Or we can actually split by ID and say the events with the ID from A to M, that's server 1, and N to Z is server 2. That is the idea of partitioning. And then you can actually go and split up the functionality. That is actually what we do in this service. So warehouse deals with ordering goods from suppliers, and the shop deals with customers. And this is different functionalities, and therefore this is the way we were splitting this. And one good reason for doing is because you would like to, well, separate the traffic. The other good reason for doing is to tackle the code size. If you have all the functionality in one service, that one is a very big monolith service, and that becomes hard to maintain. And if you split that up, then you can have two very independent services that can restart independently and that can be maintained by different people, different teams, independent of each other. They can have their own release cycles and these kinds of stuff. And that is what we actually would like to achieve in this course, finally. However, the other two dimensions of scaling need always to be considered and addressed too. And therefore, one thing is, well, they should not spam each other, but use circuit breakers is one technique that you use. And the problem with scaling is that one is hard to test. Again, hard to test. So I try to avoid problems with scaling as much as I can. I use this last known thing that we've not yet used in order to say, okay, so now the warehouse starts, the shop starts, and the warehouse tells him all about products that it knows, the warehouse knows about. So if you run that service for some years, there might be 1 million products in that warehouse. And each time you do a restart, you send over 1 million products. And that's bad. And actually you said, I already have sent you 999,000 of those, and only 100 is left. And so I would like to reduce the amount of traffic I have to these ones you do not yet know about. And then you say, oh yeah, thank you for the new ones. I still know the new ones, the old ones. Or by chance you were able to crash your event store. The shop was actually totally corrupted and all the data is gone. Then the shop would say, okay, for this one single time, it would be great to get the old stuff too. And you need to prepare for all those cases, and we do this with the last known, but actually I will not be able to do this in this course. And we'll leave that. And in addition, we would actually need to test whether this really works. And we really need to measure how much time do we save by doing so. And is this an actual problem, or we don't care because it's 2 milliseconds instead of 1 millisecond. Who cares on startup? So really, we need to think about scaling all the time, and each of the mechanisms we install, we need to ask ourselves, is this going to work still when we have 1 million customers or usages per second? Will we break down, or are we still going to work? And finally, we need to test it. And actually, that's a hard one. The last is the hard one. And there is another lecture the web engineering course. It's a master course run by Michael Lesniak usually. That will be actually held in summer this year. And I collaborate with Michael. He's actually doing old monolith web services, but he also has a lot of things going on towards stress testing, sending 100,000 requests per second, and is everything still working fine? So you will learn you need to go for that course in order to get more about these stress testing things. And there is this DevOps Technologies course that is also a master course run by Sebastian after all. And this will happen again in summer 22, most likely. We just have had it. This deals with a lot more of these resilience and scaling patterns used for microservices and how to set up a really redundant environment to get this done. So, what is the time? 15 minutes left. Great. We are not really done. Those two connect to each other, the warehouse and the shop. However, if we have a new product, so now they know about each other, they have exchanged initial information, and now some user comes and adds a new product to the warehouse. And then the warehouse should send this. Currently, only on startup, they do an exchange of information, but while they are running, they do not yet do this. And therefore, we go for the shop subscriber test, the new test. And there we just create a new product. And to make it new, well, I must either think of a new barcode each time I call this test. I was hating this. However, I also could say I have a new name each time I run this test. And I get a new name by using this $time here, and the time is the current time when the test is executed. So when the test starts, I do a new date to either string and I recall that string. And then here I actually put this in the title or the name of the famous SDM book. So it's now the SDM book from 1317. Okay. Well, it's ISO time, so it's 1217 after all. And so there's a new information. And actually, I use the old ID. I use a new event ID. So the event is having a new timestamp too, a new event date. And the user who's doing this is the shop subscriber test. And the state of the thing is created, so our test behaves like our graphical user interface and tells the warehouse, oh, I have just entered the data for a new product. And then we do this Axios post to 560, which is the warehouse, and there the submit as a graphical user interface browser would do it. And then we wait for the response state. No, we get it. Yeah, the expect actually waits for that one. No, here's an await after all, yeah. And then we ask the warehouse, do you actually have the new product? This is done all these kinds here. And it says it should have been registered. And the ID is P42 SDM book. And let's close this one in order to see the whole line, that you can actually check whether you have done the same thing in your assignment. We create the shop for the book. So we expect that those two services are both running and that they are connected. And that so if we add something to the warehouse should tell the shop. And so we should be able to ask the shop for this information, for the product. And the shop already has the product command handler. Yeah, that should work. Okay. And so there's a query. Yeah. And that one is, the topic is products, yeah, timeless thing. And the shop query is the URL where we are posting this to. So if we run that one, I have prepared that. There is a test shop gets product updates. Do you want to see how that one is called, is created? We need to edit the configuration from the, I think it's in the server shop. There's a test shop get product update, and it just says yarn run test and the name of the test I want to execute. And the request is launch node terminal. So test shop get product update, let's execute it. So we are now running 3 Java virtual machine, no, it's not Java, Node.js instances or Node.js instances. 2 services in their own JavaScript virtual machine and 1 for the test. And it says it's an error. So let's go back what's going on. So this is the test for the shop gets product update. And it does get a product for SDM book. And this was when we ask the warehouse. And it says it's 1220. And then it fails. And the position it fails is the whole thing. And there it is, we query the shop and the shop does not know. That's basically the thing. Testing exchange didn't work. And it's this line of code, signal list length to be 1, that is when we are in the line 51, which is, come on. This one here, this is in the query the shop for the book, and that one didn't work. So the shop didn't know, and no one did actually tell him. And so we need to do that. And where do we do that? Close this one, have this one here. So we are sending a submit to the warehouse. And so we go for the warehouse submit handler. Go away, submit handler of the warehouse. Believe me, that's the warehouse submit handler. And actually I go for my preparations to find the thing where I actually did this. This is the warehouse submit handler, and yeah, it should have an operation telling the other guys, here it is, yeah. And we do that, 249. So it says, put this in line 249, which is here. That is put into the event store. So when we decide that we execute an event, we finally store it in our local event store. And that's a good point in time to actually also inform other people. So at the very end, once we have stored it with insert or update, we do a publish event on ourselves. And I have prepared that one too. Here it is. So what we do is we go for a model editor that the subscribers editor, that's the guy who knows about all the people who are listening to us. And then we say, I need all the subscribers for a certain topic. And then it says, no, you do not have this method yet. So we edit. I have prepared this. And so we need to go for the subscriber editor at the server warehouse. And that's in the model. And there's the subscribers editor. Here it is. So that one was having the list of subscribers, you know. And there we put in a method, get all subscribers. And I have a get a certain subscriber. I'm not sure whether I actually need that. Get all subscribers for a certain topic. Well, we actually do a loop through all the subscribers we have and ask each of the subscribers, what is your topic? And if this is the topic I'm going to publish for, I push you to this result list, and that's what I return. Basic standard things that you usually do. And so publish event now calls this get all subscribers. Then does loop through all these subscribers and tells, oh yeah, I'm going to publish this. And then it does a post for subscriber URL and event. Could not have been easier. And if we do this right, and then we need to, well, restart a lot of things. And I just closed them all because I'm not sure which one of those I did not change yet. So, and then we start the warehouse, and the order is we don't care. I'm not sure what is going to happen when they start simultaneously. And they both try to reach the other and both fail and say, okay, I don't care anymore. They will never establish good connection. That's a problem still. Start the shop. Yeah, we give it time to start in order to ensure that our tests is not trying to accept them too early and then has to wait and this. So it got a lot of products. So we go for test the shop, get updates, and cross your fingers and pray to your God. That this works. Hey, it runs, it's fine. No, pass. Yeah, it says it passed. Yeah, it did work. So actually, it seems that the job is now, shop service is now aware of the new product. And we can actually check. So it's 12/27/19, and that is 12/27/19. That is the one that we have generated at the first run. And if we run this again, test shop get product, let's do it again. You still recall the time? Maybe we can do it again. So 12/28. It was something different last time, was it? It was, yeah. You try it at home, and that's actually what you wanted to achieve. So, yeah, great, works. Fine. So that is actually what I wanted to achieve today. And is there already an assignment 8? I'm not sure. So this is assignment 8. Make product exchange, data exchange, change work. That's the homework for this week. So what you really want to know is you need to start one server, then the other server, then add a product, and after all, both of them know about it. And then you again try to restart one of the server and do again. Restart the other one, do again, and it should work all the time. That's the 3 things I would like to see on Thursday in our Zoom sessions. Great, here we are. There's more to come. So what we actually were implementing the last 2 weeks were these things here. In order to make more of these things happening, in order to be able to get this thing longer, actually there was this thing, new product has been reaching here. So this is what we have achieved. Coming up behind that is that we need a graphical user interface for the shop, where some shop client, shop clerk, some guy working at the shop, she or he can actually add this product to the catalog to the shop to be bought. Well, we call it create an offer. Offer the product to some real world customers. And then there needs to be another user interface where real world customers can actually buy stuff. And then there should be orders for real customers. Alice wants a pair of shoes that need to be transported from the shop server to the warehouse server. And the warehouse server shall announce, oh yeah, I have sent it out, the packet out, should be there in 2 days. And actually we need to complete this cycle of things. And we will have more user interface to the shop next week. And then we will wrap up the week after that, where we will actually go through the whole cycle and see that everything is working. And then I will do some announcements, and that's actually how we would like to end the term. I hope that works out very well. And we will discuss more about these scaling testing things and whether we actually achieved all the scaling properties that we wanted to have. And we still need to deploy our service to Heroku. That's what we do in the last week, after all. That will actually need another week. So this week, we get this product exchange done. Next week, we do the ordering of products, and after that we are going to deploy all these services to the cloud in order to make them available for real-world customers. That's the idea. There was something very important coming up. Yeah, so stay tuned. Thank you for your attention, and it's only 2 minutes more than the scheduled time. This is a good day for science, and I hope you can actually do that. See you on Thursday for the grading. Bye-bye, and done.